Welcome to our second volume of Magnum Performance Video Magazine. Our first volume was met with great appreciation, so this series has been continued to give you the latest service details available. In our first story, we'll show you how to check and also how to charge the transmission control valve accumulators on all 18-speed transmissions. We'll show you the service tools you need, as well as the current component part numbers. Next, we'll review a field procedure for checking the Viscous fan drive to see if it is working properly by supplying enough cooling air across the engine components. Then we're going to introduce you to a new anoroid kit, which contains several new components to repair a possible problem with the existing fuel pump. Our Magnum audit teams have been traveling throughout the country collecting data on the quality and performance of the Magnum tractor line, and they came back with lots of good information. We'll report on 2 simple adjustments which can be made as a result of their findings. And finally, we'll show you how to modify an existing tool used for the installation of the MFD hub seal. This seal has gone through refinement since the 7100 series introduction, so we'll show you how to properly install and use the modified tool. If you have story ideas you'd like to see in upcoming issues of the Magnum Performance Video Magazine, please contact our product support group or your local parts and service manager. One of the contributing factors to a poor shift quality of the Magnum 18-speed transmission could be improper transmission control valve accumulator pressure. Effective with transmission serial number AJB0062623 for the 18-speed transmissions with creep, and serial number AJB0062654 for the standard 18-speed transmission, a pre-charge pressure change has been made. Before we discuss the changes, let's find out how to determine what the accumulator pressure is and how to measure it. It should be noted that transmission accumulators need to be periodically checked. There are 2 accumulators. The top or uppermost one is the Range Transmission Accumulator, and the lower one is the Odd-Even Shift Accumulator. We'll first check the pressure of the Range Transmission Accumulator. Install a pressure gauge to the upper port on the control valve. Now install a flow meter at the remotes to check the transmission fluid temperature. With the engine running, we'll equalize the temperature between the transmission fluid and the accumulators. Shift the transmission between forward and reverse 5 or 6 times. This will bring the accumulator up to the operating temperature of the transmission fluid. You should note this temperature at the flow meter. Now, with the shift lever in the 0 neutral position and the clutch pedal all the way up, look at the range transmission pressure gauge while shutting down the tractor. The gauge should indicate a slow pressure drop. Then it should abruptly drop off to 0. It's at the point where the pressure dropped off abruptly that you need to know, because this is the charge pressure of the accumulator. Compare this pressure reading with the chart found in Service Bulletin NTRSB01593. Our temperature was recorded at 80 degrees, and the pressure fell off at 138. Looking at the chart, we find the temperature and read the expected pressure. If your pressure readings were below that listed in the chart, the accumulator pre-charge is low. A similar procedure is used to find out the charge pressure of the odd-even accumulator. With the engine running, shift the transmission into gear. Keep the clutch pedal down, and then shut the tractor off. The odd-even transmission pressure will begin to drop off slowly, then fall off abruptly. Again, compare your readings with the temperature chart found in the service bulletin. If during these tests you notice the pressure not falling off abruptly, the accumulator pressure is low and must be recharged. Service Bulletin NTRSB01593 was published in March of 1993 and outlines the accumulator recharge procedure. The pre-charge pressure is now set at 135 psi for the odd-even accumulator as well as the range accumulator. You must have the accumulator charging kit, part number CAS10899, as well as the accumulator tester gauge, CAS1975. You will also need a cylinder of dry nitrogen. The following procedure was completed at an ambient temperature of 70 degrees Fahrenheit. Install the accumulator tester gauge to the accumulator. Then turn the T-handle shutoff valve clockwise. Install the hose from the charging kit to the nitrogen supply. Then connect the other end to the gauge assembly on the accumulator. Now slowly open the regulator valve until the needle on the gauge reads 135 psi. Be careful not to overcharge the accumulator. Close the valve on the accumulator charging kit. Then turn the T-handle shutoff valve counterclockwise. Replace the cap to the accumulator stem before attaching the accumulator to the transmission control valve. For further information regarding the pre-charge pressure change and charging procedures, refer to Service Bulletin NTRSB01593. Remember, the bulletin contains a pressure and temperature chart that you can use during the accumulator checking and charging procedures. Have you ever tried to troubleshoot a cooling complaint or a hydraulic heating complaint and not been able to find an obvious cause? One of the simplest checks you can make is to verify the operation of the Viscous fan drive on 7100 and 7200 series Magnums, because without enough air passing through both the radiator and oil cooler, overheating complaints can arise. This story will show you how to check the speed and operation of the Viscous fan drive. A photo tachometer will be used to get an accurate reading of the fan speed during operation. Prior to checking the fan drive, complete the following checklist. First, look at the drive exterior to see if it might be bent or broken. Are there any missing parts that could cause a failure? There is a bimetal strip located on the front of the drive. Is it there? Don't remove it if it is, because the fluid inside the drive will leak out. Don't steam clean the area. Steam cleaning can force unwanted debris through the seals and contaminate the grease or silicone fluid inside the drive mechanism. And finally, never attempt to restrict the rotation of the fan blade during engine operation. Remember, the entire area must be clean and free of debris. Check the oil cooler for any crop residue. Also, check the air conditioning condenser and radiator fins before testing the fan drive. Although this seems simple and common sense, if this area is not clean, the performance of the cooling action can be greatly affected. The first step in using the digital photo tack is to place a small piece of reflective tape on the engine side of the fan blade. You can stick it near the outside edge of the blade. In this area will be fine. Now take the photo pickup and its magnetic base and position it on the front left side panel bracket. Then aim the pickup at the reflective tape on the fan blade. Run the tack wire up to the cab. You'll use it with the tachometer in a moment. Now carefully close the hood, making sure the wire does not get pinched. Next, install a flow meter in one of the remote circuits of the hydraulic system. We'll use the flow meter to provide a load to the hydraulic system. In order to get the engine compartment hot, it's necessary to cover the front grille screen. With the engine running, use a large piece of plastic to cover the front grille. Smaller pieces of plastic are used to cover the small side panel screens. This procedure will get the engine compartment up to temperature. Check to be sure the tachometer is turned on. Then run the engine RPM up to 2200. Set the flow meter to 2000 psi at maximum flow. Be sure to keep the engine running at 2200 RPM. The engine coolant temperature will begin to rise on the instrument cluster. When it reaches 8 bars, the fan drive should be fully engaged. The fan speed is indicated on the photo tachometer, but because the grill screens are covered, it may not be up to maximum speed. To get an accurate reading of the fan speed, remove the plastic from the front and side grill screens. Now read the photo tachometer. It should read a minimum speed of 2180 RPM for all 7100s, 7220s, 30s, and 40s. The 71 and 7250 fan speed should be a minimum of 2300 RPM. If the fan speed is under the minimum speeds listed, the Viscous fan drive is defective and must be replaced. Further information regarding the field test procedure for the Viscous fan drive can be found in Service Bulletin NTRSB01593. This simple test can help you find the reasons behind an overheating problem that is sometimes difficult to diagnose. A new anoroid cover kit has been made available for all fuel injection pumps mounted to the 7150 and 7250 tractor engines. Kit part number A77821 is available to correct for cracking of the anoroid cover around the air control line fitting. The kit contains an anoroid cover, an elbow fitting, a flexible air control line, and 2 copper seals. In order to install the kit, you'll also need a new anti-tamper seal wire. You can order a new wire using part number 678026C1 and a new seal lock, part number 687459C1. Let's review the installation procedures for the anoroid kit. For demonstration purposes, we'll show the following procedure on a pump which has been removed from the engine. Be sure to clean the entire area around the anoroid. Remove the anoroid control air line from the intake manifold. This air line will be replaced with a new one. Remove the seal wire from the adjusting cap nut on top of the cover. Then remove the 4 anoroid cover mounting screws. Now, carefully remove the cover. Be careful you don't disturb the diaphragm. If you were to damage the diaphragm, the entire injection pump would have to be removed and repaired by an authorized diesel repair station. The anoroid mounting flange surface should be cleaned next. This can be done by using a soft, lintless shop towel. Using a depth micrometer, measure the distance from the tip of the adjusting screw to the anoroid cover mounting flange. This distance should be recorded since we'll have to use this measurement during installation of the new cover. Now remove the cap nut, jam nut, and the adjusting screw and sealing washers from the old cover. The cap nut, adjusting screw, and jam nut will be installed into the new cover. However, we will use new sealing washers. Now, install the adjusting screw and jam nut to the new anoroid cover. Be sure to use a new copper sealing washer. Using the depth micrometer, turn the adjusting screw to the length recorded earlier. This adjustment is critical. Once you have made the adjustment, lock the jam nut. Install a new sealing washer over the adjusting screw and replace the cap nut. Tighten the cap nut while holding the jam nut in place. You can now return the new cover to the fuel pump. Tighten the 4 mounting screws to 43 to 52 inch-pounds. The new anti-tamper seal wire can then be installed to the cap nut, jam nut, and 1 cover bolt. Crimp on a new seal lock. To install the threaded elbow fitting, use Loctite thread sealant with Teflon on the threads. Now install the new elbow to the cover. Tighten the elbow in place so that the inlet is pointing straight down. Next, install the new flexible air control line to the elbow. The nut is tightened down until it makes contact with the fitting. The other end of the air control line is fastened to the intake manifold. The new anoroid cover has been successfully installed. For further information regarding the kit, its components, and installation instructions, refer to Service Bulletin NTRSB01593. There are a number of small items which get changed during the manufacturing process of the Magnum tractor line. Many of these changes are the result of the product audit team which visits owners and their tractors periodically throughout the year. Other changes are in response to dealer and owner inquiries. 2 such items are the latches on both the hood and the cab door. At times, it was noticed by our customers that the cab door handle would strike the rear of the slot prior to activating the door latch. Starting with the 7200 series tractors, a welded bracket was relocated in order to ensure proper mechanical action of the door cable. The door cable itself was also changed in the process. The new part number for the cable is 1340019C3. This cable is 2 millimeters shorter than the old cable. One other change to the door latch was made by removing a rubber spring cover. This spring returns the door latch cable and handle to the latched position. These new changes to the door latch assembly went into effect since tractor serial number JJA0052125. If your customer complains about his door latch, the new cable can be ordered and installed to correct the problem. Another item found during the audit was the hood latch adjustment out of tolerance. Whenever the operator would try to raise the hood, he would have to use excessive force on the release lever. This is a simple fix. Readjust the hood stop bolts by lengthening them by 1/2 turn. This will correct the condition so the operator can more easily release the hood latch. The latch should work nearly effortlessly. Our audit team found several late model 7200 Magnums to have this misadjustment and was quickly remedied during the inspection process. Our commitment to quality continues to thrive. Let us know if there are additional items of concern so we may suggest future product enhancements. Due to a change in the design of the mechanical front-wheel drive hub seal, rework of the installation tool is required. This new seal, part number 128648A1, incorporates a dust wiper and excluder seal. It has proven to last over 300% longer than the original seal placed in the 7100 series tractors. Midway through the production of the 7100 series tractors, an additional excluder seal, part number 134939C1, was incorporated along with the original hub seal. This seal was introduced to service technicians in Service Bulletin NTRSB04091. This additional excluder seal is also retained on the 7200 series tractors. The new MFD hub seal can be installed on 7100 series tractors with or without the additional excluder seal being in place. However, slight rework of the installation tool is required. Seal installation tool CAS1900 needs 2 machining operations to make it compatible with the new seal. First, a counter bore needs to be machined into the tool at a depth of 0.14 to 0.18 inches in depth. And second, 2 chamfers are needed on the tool's radius. The chamfers are set at 45 degrees and have a dimension of 0.020 to 0.060 inches. When installing the new seal, the inner lip does not come into contact with the installation tool. Service Bulletin NTRSB01593 contains details regarding the modifications to the installation tool and the effective serial numbers of the components involved. You may also wish to consult Service Bulletin NTRSB04091 for information regarding the excluder seal.